So hello everyone, and thank you for joining us today in the first webinar that we're making about BufferFish. This is the new Wiris product that is quite different from the products you have seen before in Wiris, and we are super excited to introduce it to you. This webinar is 1 hour webinar, and wait, I'm gonna open the chat here so I can see if you, so this webinar is going to be a presentation. After the presentation, we're going to make a demo session. And after that, we're going to make a Q&A session. So if you have any question during the presentation, so you don't forget how to ask it, you can write down in the chat. You can write it. There is also a questions and answer section, so you can write down your questions there. And once we finish the demo session, we can start answering all the questions you may have. So first of all, who are we? I'm going to introduce ourselves. So Ludmila, she's my colleague. She had a PhD in biochemistry, and she comes with more than 12 years of experience working in the laboratory. So basically, she's the one that have been giving us all her knowledge about how the life of the laboratory is, and she has all the technical knowledge about it. I am Laura Hernandez. I am the product manager of BufferFish, and I'm gonna drive you today through a presentation with the key industries insights that we have, what are our target audience that we are, so the audience that we're targeting with BufferFish, what are the pain points, and what solution we are bringing to them. After that, Ludmila is gonna make a demo with you so you can see the concentration calculator, which is the first feature that we have released from BufferFish. And after that, as I said, we have the Q&A session. You have our mails here, just in case you want to contact with us directly. So if you have any questions or you want to comment anything with us, do not hesitate to contact us. So let's get started. As I said, this is the new Wiris product that we're introducing that is quite different from the rest. Why so? As you may know, in Wiris, we count with more than 20 years experience on mathematics products, like math type with quizzes. I think all of you may know this. So the biggest change is that we are making an evolution. We are going from mathematics to life science with BufferFish. This is the first product that we just have that is completely focused on life science. Also, with math type and Wiris quizzes, we have been mainly focused on academia. It's true that we are also targeting some industry, but with BufferFish and with this new study field that we are approaching also new industries, like completely new industries that you have never worked before with Wiris. Which kind of industries are these that we are targeting right now? So we have industries like biotechnology, pharma and medical, fundamental research. Also, we have something like academia, and also we are targeting some industries of goods that you can have in your house, and companies are big companies and small companies that are producing food and beverage, cosmetics, or even the cleaning products that you have on your house. We have many other industries. We try to draw like the main ones, but there are many others because the research in chemistry and biochemistry is widely extended. So there are many other industries that we can address. We try to map the most important ones. Inside of these industries, who are we targeting? So who is the target audience that we are targeting with this new product? So mainly it's people that is working in research and development in laboratories of research and development in life science. Who is these people? It could be masters and PhD students, as you know. Well, in life science, and normally in science in general, it's very common that people do masters and also PhD is widely extended. So these people, what they do meanwhile they are studying the master or the PhD, they are basically the whole day in the laboratory making some experiments, complementing some investigation for the thesis and so on. So this is one of the target audience. Then we have also lab technicians. These people that have professional formation, so this is people that is working in the labs. They are carrying out all the experiments, like working physically in the lab. Then we have scientists. This is people that they have finished all their study and they have been working already in the laboratory. They have some experience. They have another level of seniority regarding the other two ones. And these guys are also not only executing the experiments, because they can be doing like carrying out physically the experiments or not, but basically these people is more designing these experiments that afterwards are going to be carried out. And then we have lab managers. These people, so this is the manager of the lab. These people is not literally working in the lab, but they are users. They consume the information that is produced in the lab. So all the results of the experiments that the other people does. Just to put you a bit in context, how are they in the laboratory? So you have to make an experiment. So before carrying out the experiment, you have to make some calculations. Then you go to the laboratory and you physically do these experiments. You have some like with the machines, with all the things that you need. These experiments will bring you some results that you have to analyze, and you have to put it in a nice report and then send it to your manager. And then the manager has to take these reports and send it to the users of this information. Like it could be internally to other colleagues inside the company, or maybe it's externally to another company. So in this workflow, what pain points we have detected in what things that these people what things these people is experimenting on the daily work. We have detected some pain points of this audience. We have put them in four categories. And these are like the most common. Of course, if you go into every different target audience, each of the different segments, you're going to have more specified, but these are more general. So it's just to give you an overview. There is a lot of loss of time due to doing boring and repetitive tasks like calculations, manual checkup for information. They are working with zillions of different components, and they have to be checking characteristics of these different ingredients. So there is a lot of time doing all this research, all these calculations. There was this guy that we interviewed. He's a PhD student, and he said he used to spend from 10 to 15 hours per week just for the calculations, not carrying out the experiment, which is the thing like they have been more focused on, but just on calculations. Another thing they normally complain is there is not a single software that integrates all the functionalities they need across the workflow that I described before in the lab. Maybe you have a software that analyzes chromatography. Maybe you have another software that analyzes other things, and the results. One result comes in PDF, another result comes in the version that software of this specific experiment does. So then they have to put everything together, analyze it together. Maybe they have to go to another tool like InDesign, or they have to go to PowerPoint to put everything together. So there is not a single software that integrates everything. And also the software that they have right now are super old-fashioned. They look like these Windows 98 programs with these big buttons, very like not very visual, not very easy to use. Another thing is there is a lot of inefficient in documentation and sharing. Documentation is a super important part of the process, because you have to document everything that you do in order you have to have a track on what you do, and also to share. You have to share to your manager, you have to share to your colleagues. And I was really shocked, because I have seen, like, talking to final users, that most of them still have paper notebooks. So they do manually the calculations, or they write them down in their notebooks, and then if they leave the laboratory, they have to just pass the notebook to the next one, and good luck if you understand my handwriting. And so it's very inefficient the way that they have right now to document or to share. Or as I was saying before, you have different software giving you different information. So one is in PDF, one is in another format. So it's difficult to document for them. And then also so all these things introduce a lot of mistakes. like human mistakes, when you're making your calculations by hand, or when you write something, or when you're typing something and you put an extra zero, that changes everything. And if you notice that you're introducing mistakes, then you have a loss of time also, because you have to be redoing everything that you have done before. So how we want to solve these problems that we have, that our target audience has? Well, with BufferFish, we want to introduce a tool that saves time to the users, that is easy to use, and it's ready to document and to share anything. With time saver, we're introducing automatic calculations, so in different ways. We have automatic calculations for concentration solutions. We have automatic calculations to calculate some parameters of proteins in multi-sequence. That is really going to save a lot of time to our users. With this automatization, we are trying to avoid these human mistakes. And also, we are trying to make less iterations when managing the results. So if you have everything centralized in one place and you can be editing your results, so it's to reduce all the iterations you have to do when you have different results and you have to put them all together. We also want to introduce a really easy to use solution. You're gonna see afterwards when Ludmila show you the demo. It's very user-friendly web app. You don't even have to download, it's everything online. And you're gonna see super clear results, are super easy to see, super easy to manage. You don't need to remember formulas. You don't have to be checking out for how was this calculated again. No, you don't have to remember anything. And also we have to give this ease of use in the way to visualize, and also to process all the information that you have from different results analysis, like when image results analysis or charts results analysis. And also we want to make everything like super easy to document and super easy to share. And we don't want just to give one solution. We want to give the solution in order to document or share in the way that that fits or that suits each one's workflow. If you want to download your results in PDF, you can do it. If you want to print them, you can do it. If you want to make it in an interactive format, you can do it, and also be editing it afterwards. So we think that this documentation and sharing phase is very important. So we are trying that all the features that integrates BufferFish has this feature. So what are the functionalities that people can do with BufferFish? Basically, we can resume them. We can sum up them in three. So with BufferFish, you can make calculations. You can make analysis and visualization of results, and you can also document and share, as I said before. So if you remember the workflow that I introduced you before, we can do everything, but going with you to the lab and physically make all the calculations. Then BufferFish is gonna come with 5 different features under this umbrella of the functionalities that I mentioned before. So the features that that will help you to calculate are going to be concentration calculator, the unit converter, and the protein calculator. Concentration calculator, this is the one that Vilas going to explain you more in detail afterwards, but basically is to make calculations of the concentration of all kind of your solutions. The unit converter is a converter between units, that what it's meant to reduce the human mistakes we have been talking before. And also we have the protein calculator, which is to make some parameter calculations of your protein sequences. We want to make it like multi-sequences calculations, like extinction coefficient, or you can calculate also the molecular weight of your protein sequences. Then about analyzing and visualization, we have the gel analysis tool and the chromatography visualization. The gel analysis tool is going to help you to analyze your gels images, detecting the lanes and the bands, and providing you space to label them. So it would be super easy to manage the results and to label the results. But this is something that normally is not easily made in one program, but you have to go to PowerPoint, you have to other way and go and be putting all these tabs. And then the chromatography visualization is going to help you to visualize your charts, not only your chromatograms, but all your charts, detecting your peaks and also helping you to label all of them. So it would be super easy to analyze the results. And of course, all of them, as I said before, would be ready to document and share. So we want to provide all the tools you're gonna see now. Out of the 5 features, we have thought for BufferFish to be like the ultimate product, like as BufferFish, as a complete solution. 2 weeks ago, we just have released the concentration calculator. The rest of the feature, we are already working on it, and there will be soon. But the only one that is right now available is the concentration calculator. And now my colleague Lyudmila is going to drive you through is going to give you an overview of the web app, and she's going to introduce you to the concentration calculator. So I'm going to stop sharing my screen so she can be in control of it.
Hello, guys. My name is Lyudmila Filonova, and as Laura said, I'm a biochemist. I was working in the lab for about 13 years, maybe a little bit more if you count the university. And yeah, now I'm helping companies to develop software for the labs because I know how the labs work from the inside. So let me start sharing my screen. You should be seeing my screen by now. Laura, please confirm. Yeah, so, and I will introduce you to the application concentration calculator and what it can do and why we think it is cooler than Excel, for example. So here is the concentration calculator. Here's the page, how it looks when you enter the application. Let me guide you step by step. First, which blocks do we see on this page? Let's look first, let's look at this blue bar at the left side. So here you have the list of all the features that are available, that will be available in BufferFish. At the moment, only the concentration calculator tool is available, so it's active, and the other features are listed as coming soon. As soon as we will release them, they will appear as active features, and you can switch between them. Down here, you see 2 links to frequently asked questions and contact us page in case you need more information about how concentration calculator works, or if you have any feedback for us, please don't hesitate to write us anything. If you have any wish list of features that you would like to have, you are welcome to write. Okay, what do we see on the top? Here is the name of the active feature. Again, right now, only the concentration calculator is available. So it's the name of the concentration calculator that you see here. But when you will be switching between the features, you will see protein calculator here, for example, or gel analysis or whatever you are using. On the top right side, there is a navigation bar. I will explain it a bit later after we have prepared the recipe, because it will make more sense a bit later. And this in the middle is the main window that we have for making calculations. So with this, we can create a chemical recipe that you will use for your protocol, for preparing your solutions. Let's see how it works. So first field, solution name, quite obvious what we should input here. So let's say I will make a demonstration of preparing a typical buffer that I use to prepare for my proteins in the lab. So let's call it protein storage buffer. So protein storage buffer, whatever name you prefer. Here you input the final volume of the solution that you need to prepare, your final volume. Let's say in my case, it will be 1 liter. Here, the drop-down menu allows you to choose between liters, milliliters, microliters, and nanoliters. So don't expect nanoliters to be used a lot, but it could be if you are calculating something for the pipetting row. But well, anyways, just in case it is there. Let's say today we are preparing 1 liter of my protein storage buffer. Let's see what else do we have. Now we come to ingredients part of the calculations. The first ingredient is diluent. In my case, diluent will be water. It can be any other, of course, any other diluent that you are working with. Can be whatever, acetonitrile, ethanol, whatever. In my case, it's water, because I think in many cases it's still water. As you could see probably, as soon as I entered something in this field, the amount of diluent appeared here. Now it equals to 1 liter, which is the same as the final volume that we want to prepare. Why is this? Because we did not input any ingredients yet. As soon as we will add ingredients, the amount of diluent you need to add till the final volume will be recalculated appropriately. Down here, we have the line to start inputting ingredients. Let me guide you, because each of them has some menus. Let me guide you through them. So ingredient name, it's quite clear what this can be. Let's say I will be making tris buffer, so I will put tris here. Then the type of ingredient. You can choose between liquid and solid. Liquid if you have liquid stocks or liquid prepared, or liquid ingredients. Solid if you are preparing something from the powders. Why you need to choose the appropriate type? Because, well, obviously, then different formula is used for calculation of the amount of ingredients. So you have to choose it here so that the correct formula is used for the calculation. Next field is initial concentration in case my ingredient is liquid, or molecular weight in case my ingredient will be solid. But right now it will be liquid. Let's see which options we have in liquid ingredients. You can use for calculation molar concentrations. Again, you have molar, millimolar, micromolar, nanomolar, depending on your needs. Then you have weight per volume units, grams per liter, micrograms per microliter, and so on. And the one interesting here is percent weight per volume. I will explain it a little bit later in a little bit more detail how it's working, because it's different from gram per liter. And in the category volume per volume, you can choose between units per milliliter, which is typically used if you are calculating for enzymes, for example, percentage volume per volume, and X. X means X time dilutions. As you might know, it is very typical in the lab to prepare, for example, 10 times concentrated stock or 5 times concentrated stock. So X means X time dilutions. Those who work in the lab know what 10 times concentrated stock is. It means you have to dilute it 10 times, or 5 or 2 or whatever. And in the field final concentration, well, you input the final concentration that you want to prepare. So let's see how this works. Let's say my first ingredient is tris. It is liquid because I have prepared a liquid stock already. And let's say I have 1 molar liquid stock. So in this case, 1 is initial concentration. And let's say I want final concentration 200 millimolar. So we put 200 millimolar here. And you see that the calculation happens immediately. As soon as you have all the numbers, all the necessary numbers input, you have the amount that you need to put. Okay, now I want to add more ingredients to my recipe. So we click this nice button, add ingredients. You add as many ingredients as you need. At the moment, the calculator allows you to add up to 30 ingredients. To be honest, I've never seen in my life that anybody would need so many of them, but in case you're working on something that requires more than 30 ingredients, please let us know and we can easily fix this. So now let's input the next ingredient that will be, for example, sodium chloride. And let's say I do not have any liquid stock of that, so I have to prepare it from the powder that I have on the shelf. So I have to choose that it's solid. In this case, the units here changed for gram per mole, which is molecular weight. So the number that we will have to input here will be molecular weight, which is, I think it is 58.4 for sodium chloride. And let's say the final concentration of solution that I want to prepare is maybe 100 millimolar. 100 millimolar, about 5 grams I have to add for 1 liter. So which other options do we have if in category of solid ingredients? Well, let's actually choose the next one. Let's make it solid and see which options do we have in this drop down. We have gram per mole if you are preparing molar concentration from a solid stock, from a powder. You can also choose weight per volume here. If I'm preparing from the powder something that is 2 milligrams per milliliter, for example, and solid percent. I think it's quite clear. What is that? Like 1 gram per 100 milliliter. So let's see how this works. Imagine next ingredient I want to put, for example, it can be BSA. Sometimes it's nice to have BSA as a protein, but sometimes it's nice to have it in the buffer because it prevents the protein of interest that it sticks to the walls of my tube and so on. So let's say we want to add BSA, and we want to add BSA to final concentration 8 milligrams per milliliter. So here in initial concentration, well, that is not, initial concentration is not applicable in this case, but in this field, I will choose the option weight per volume because I want to prepare 8 milligrams per milliliter. In final concentration, now it gives me the option to choose milligrams per milliliter because I chose weight per volume. So let's choose milligrams per milliliter and we'll say 8. So I have the powder, initial concentration is not applied in this case, and the final concentration I want to have 8 milligrams per milliliter. Fine, we have our calculation here. Let me show you another ingredient. Let's say I want also to have glycerol in my buffer. That it also doesn't hurt to have in storage buffers for proteins. So here is an interesting case that I want to show you too. Glycerol. Glycerol is a liquid ingredient. So we choose a liquid type here. But as you might know, glycerol is a very, very viscous liquid, 100% glycerol or 99% that it's normally is normally manufactured. It is a super viscous liquid. Therefore, it is very difficult to measure it by volume because, yeah, it will be sticky. The volume will not be so precise. So the trick here is to measure the glycerol by weight to have the correct final concentration. So even though this ingredient is liquid, there is an option to measure it by weight. So we choose weight per volume option here, and we choose percent. In this case, the initial concentration field also becomes inactive because this does not apply, but we can input our final desired concentration here. That is, for example, 20%. And we have our calculation here made. Oh, and now let's say I'm ready with my buffer. I don't need this line of ingredient anymore. I am happy with 4 ingredients, so I can delete the line by pressing the cross here. Perfect. Now I have calculated my recipe. This is what I'm going to prepare in the lab. Important thing that I would like also to mention to you is, as soon as you have at least one solid ingredient in the recipe, the final amount of diluent cannot be calculated because it cannot, the volume of the powders is difficult to measure properly. So instead of calculation, instead of a number here, you will see the message up to 1 liter. So you would know that if you are preparing this buffer, you would need to use measuring cylinder and to adjust your volume till the final desired volume that you have, 1 liter, half a liter, whatever. Fine. Now I'm ready with my recipe. What can I do with it? Right now, let's have a look at this navigation bar at the top right corner here. Of course, I want to save this recipe because maybe this is a buffer that I'm going to be preparing very often. First thing you can do is you can download JSON. JSON is a format that allows you to save templates and to edit your recipe later. This is what Laura was explaining, that when she said that we will have like editable interactive results. You can save this as a template, and if today I'm preparing 1 liter and tomorrow I want to prepare 2 liters of the same, I will have to just upload my saved recipe and just change one number here, and my calculation is done in 1 second. So let's do it. Download JSON. By default, the file will have the name protein storage buffer, the same name that I have input in the solution name. So let's save this recipe. Now it's saved in the interactive format. Imagine I finished with this recipe and I want to prepare the next one. Next thing I can do, I can delete all by pressing this button here. Are you sure you want to delete this solution? Yes, delete, because I'm going to calculate another one. Just to show you how this works, we can upload the recipe that we have previously saved. So by clicking here, upload JSON. Here is my protein storage buffer that I have just saved. We open it, all my calculations are here. And well, today, let's say I want to cook 2 liters instead of 1. And all the calculations, you have it immediately. Okay, the next thing that we can do, we can export our recipe as a PDF. In case you need to keep this information as documentation, in case you want to attach a PDF to your electronic lab notebook, to send it to your colleague, whatever. So again, the name is the same as your solution name. We save the PDF and let's see how it looks. It provides you, maybe I can make it a little bit bigger. Yeah, it automatically generates this nice table that is highlighted different ingredients that I think is better readable in this way. And yeah, here is your recipe in PDF. And last thing you can do is print your recipe directly from the application in case you need a paper version to, for example, you print it out and you go to the lab to pipe it, or you want to attach it to your paper lab notebook if you are using it. So you can print it directly from here. This is what we can do with our recipes. If you have, with this, I finish the demonstration. If you have any questions how the calculator works, please please ask in questions and answers below. And we go on, at this moment, we go on with the presentation. So just give me 1 second. Yes, so let me highlight for you which features we think are cool about the concentration calculator, why we think it's better than existing tools, and well, yeah. Let me introduce you. The first important thing to notice here is automatic, that all the calculations are done automatically. There is no need to remember any formulas. As you could see, you can calculate molar concentrations, milligram per milliliters, percent concentrations for solids, for liquids, prepare molar solutions from powders. Like, you need to remember a different formula for each of these calculations, which sometimes is a pain for scientists. Sometimes you have to Google because you don't remember how exactly it was. So obviously all these formulas are pre-programmed. You don't need to remember anything. You just need to input the data. I want today the 4 millimolar whatever solution, and you get the number immediately. So the calculator allows you to add up to 30 ingredients. I think this is really a lot. You don't need so many normally. Yeah, because as far as I know, most of the calculators available online only allow you to calculate 1 ingredient at a time, which is not much useful if you are working in the labs like a proper scientist. We can combine in one and the same recipe calculations using different concentration units. That would be molar, milligrams per milliliter, percentage, whatever, as you could see, solids and liquids. Then there is one thing, automatic units conversion. What does it mean? Very often, like I know this from my personal experience, very often scientists need to recalculate on the go. Oh, I have the concentration in molar, but I need the micromolar, or convert milligrams to micrograms, and all this kind of millis to micros, all these kind of things. This is a pain again. And this also, I have to say, this also, converting this just in your head also introduces errors many times, because you forgot to put 1 0 out of 6 in your calculations or something like that. Again, you don't need to take care of this anymore, because calculator, you just choose millimolar, micromolar, and calculator knows how to convert it already. You don't have to recalculate it yourself. Also, we have automatic adjustment of calculated numbers. It means that calculator automatically defines which is, when you see the final result, which number is better readable for humans. For example, instead of seeing 0.000002 liters, you will see 2 microliters, which is much better for the human to read. And you already saw the options for the results export that we have. You can export templates, editable templates that you can edit in 1 click sometimes. That saves you a lot of time in JSON format. You can have PDF in case you need to attach to electronic lab notebook or anywhere else to send to someone. And you can print immediately in case you need paper version. Yeah, with this, we finish with concentration calculator. And we start the questions and answers session. So I think, Laura, your word again.
Thank you, Ludmila, for the demo. And yeah, we have a question from Vlad. He asks, what about crystal hydrates?
Sorry, can you read again?
What about crystal hydrates?
To be honest, I'm not sure what what this means. Crystal hydrates?
Yeah.
To be honest, I don't know what this means. If you could specify your question somehow.
Yeah.
Nice.
Maybe Vlad, you can write down, you can elaborate more your question, or maybe you can send an email to Lyudmila or to both of us, and maybe she can reply to you. And then he says also, and you say one solid component generates up to volume, but this is also valid for liquids too. Yeah, the thing is, like, when we have all the ingredients are liquids, in the diluent category, you're gonna have exactly the amount in liters or milliliters of volume that you need. The thing is, once you introduce one solid ingredient, we cannot say like how many liters you have or to add as diluent, so we just say up to, and then the final volume.
Laura, maybe I can comment this one.
Of course.
This is completely true that this is valid for liquids too. For if you are dealing with large volumes, as like preparing 1 liter of buffer, yeah, typically you use a measuring cylinder, and you anyways add up your volume till the final till the number that you need in the measuring cylinder. However, if you are dealing with samples with very small volumes in microliter range, like whatever protein solutions, in this case, you cannot use a measuring cylinder. So in this case, if all ingredients are liquid, the only way to know the amount of your diluent is to calculate it. If you know that you have to add up, at the end you have to add up, I don't know, 27 microliters of water, you have to calculate it. Otherwise, you don't have the appropriate volume. Also, I have to comment something here that, well, I did not make it in the command demonstration, but we have it in our frequently asked questions section on the website, which is, yes, we know that when you are mixing liquids, some volumes do not add up. For example, if you are mixing water and ethanol. In such a case, we recommend, well, we assume that typically in such a case, the calculator will do the calculations. Yes, but we assume that scientists should know if they are dealing with liquids which upon mixing do not add up volumes correctly, and well, then you have to use measuring cylinder. There is no other way around it. I'm sorry, but yeah, you have to know this. I hope I answered the question. If there are more comments, yes, please let us know.
Well, thanks. There is another question from Umer. He asks, is there any formula to find the mass of 1 liter of different liquids?
The mass of 1 liter of different liquids? No, this concentration calculator is not meant for this. In case this is something you are doing regularly, maybe you can write to us, and we can, yeah, you explain your necessity to us, and maybe we can release the next feature about this. But no, this calculator is not meant for this.
Yeah, this is very important because, as you know, we just released the concentration calculator, and we are super open for feedback. And so, if you need any functionality that you think is interesting and you think is going to make your life at the lab easier, please contact us, and we are super open to listen all the suggestions and all the feedback that you might have. We are actually in beta version right now, so if you have anything that you think that could be improved, or anything that you think that can be changed, please let us know, and we would be super happy to provide the best solution that you can find. Thanks you, Yumer. Is there any other question? I'm gonna open the chat. See. One question. So there is a question in the chat from John. One question: is your app BufferFish available on mobile? Not now. So you cannot open the web app on your phone. But this is something we have been receiving a lot of feedback of people wanting it on the phone. So this is something we are studying that maybe could be one of the future devices that we can support with BufferFish. A ver, wait. I'm seeing now some questions. I don't know, Mila, you can open also the chat.
Yeah, maybe I can stop
because
sharing
Vlad,
and open the
Vlad
chat.
was replying something in the chat. He was saying.
Shall I check the chat or questions and answers? I'm sorry.
Chat, the chat.
Chat. I'm looking. The question. Natrium, sodium, H3 is used as a solid. Question. I understand what the question about crystal hydrates now. I forgot the term. Yeah, there are salts that whatever you give the example of sodium carbonate, I think per 10 waters. Yeah, that it happens also with phosphates, for example, as far as I know. The thing here is that typically if you have this salt, these hydrates, you have to use the molecular weight that is written on the jar, because yeah, for example, I know potassium phosphate salts of sodium or potassium, they can come with different amount of water molecules in them. So simply use the appropriate molecular weight that is written by the manufacturer, and then the calculation should be correct. Unless your salt has been on the shelf for super long time and got hydrated, but then I guess it's not possible to make a super precise calculation. Any other questions in the chat? I'm checking. One question for mobile. I think most of the stocks solids are with water. So this is a must, but you need to wait the hydrate, not the anhydrous. Well, yeah, you're waiting. Maybe I misunderstand something, but yeah, typically you're waiting the hydrate, but then you take into account the molecular mass of water that is already, well, it's like present there. So maybe, like for me, I don't see any contradiction here. I'm talking to Vlad. So if you want, you can write to me personally and we'll go on with this conversation, because I don't see any contradiction right now.
Okay, he said he will wait to you.
Okay, thank you.
Nice, thank you, Vlad. Question to our users. How much does it cost, says John? Well, for now, and as I said before, we are in beta version. So for now, it's free of charge. So you can use it. You can try it. You can use it. Once we are not in beta anymore, this might change. But for now, you can enjoy and you can use it, and you can use it as much as you want. Alberto is asking questions for the users. Alberto is the QA lead from Wiris. For people that doesn't know, well, he asked something to the users that are listening to us now. That which is your favorite device in the lab? Do you use PC, mobile, or tablets? Well, maybe this is something that we can send maybe a brief questionnaire to the participants, maybe if they want to share this kind of insights with them. Alberto is saying that he was hoping that people could write in the chat. Well, if you can write yes, otherwise we can make another. I think maybe for another session this feedback compilation. Well, I don't know if there is any other question. We have 11 minutes more. So if you have any other question, please feel free to ask. Okay, so glad is saying thanks. We'll be in touch. Okay, thank you so much. We will be very glad to talk to you, and so you can have. I think you have a intense discussion with my colleague Lyudmila. So maybe you can be discussing these technical things. Okay, guys. If anyone doesn't have any other, yeah, I guess you're a chemist. In case, so if anyone doesn't have any other question, thank you so much for attending, and please contact us if you have any question. If you want to know more about BufferFish, feel free to contact me or contact Lyudmila. You can also contact us at info@BufferFish if you need anything. And please try the calculator. And if you think there is something that could be improved, or there is something that you think it will really add value to your daily life, something, please let us know, because we will be super happy to hear all this feedback from you. Okay, thank you so much, and enjoy your day. Bye-bye.
Thanks for coming. Bye. Have a good day.